Hi everyone. Hoping this can be a quick video. The section 4.6 really mostly focuses on the log rule for integration, which we actually already know. Um, but it kind of dives in a little more deeply now that we know the idea of U substitution. So just kind of quick reminder, and also you can take these notes in like your notebook. Derivative of natural log of U, we would do 1 over the inside times the derivative of the inside, which we could also write as u prime over u. And so what that means for us is that if we have the integral of u prime over u, it's going to take us back to that original natural log of, and in order to make sure it works with natural log, we got to have those absolute values there, plus c. So we're really going to look for this situation, like u prime over u. We're really looking for that. So we've got some examples here that we'll work on. First one, we got integral of 2x squared minus 3 over 2x cubed minus 9x dx. Again, similar spot here. We're kind of looking for some part of this function that the derivative shows up later, and specifically with the log rule, where the function on the bottom, its derivative is on the top. And if we set this up as u equals 2x cubed minus 9x, then we would have du equals, like we're just doing a u substitution, 6x squared minus 9 dx. And that's pretty close to this, but I just got to factor out a 3, or divide it by 3. And so if I divide this, by 3 and divide this by 3, I'd have 1/3 du equals 2x squared minus 3 dx, and that's what's on the top there. So now I can make my u substitution. 1/3 is going to be in front, integral, and now it's 1 over u, and the 2x squared minus 3 dx is my du, along with the 1/3 that I already put in front. Well, this I know the answer to. 1/3 natural log absolute value of u plus c, and then I can plug my u back in. 1/3 natural log absolute value of 2x cubed minus 9x plus c. So the idea here is just kind of recognizing that this is set up where we've got function and its derivative on the top. That's our log rule, so it's going to be a pretty nice u substitution for log rule. Let's take a look at problem 2. As always, pause or rewind if you need to. Here, again, I'm kind of like, I've got this fraction here, and I'm thinking, ooh, derivative of sine is cosine. Great. So I can start my u substitution with u is sine of 2x, and du is going to be cosine of 2x, but chain rule tells me I have to multiply it by 2, dx. That's perfect. It matches exactly what I wanted. Boom, boom. So we have integral of 1 over u du. There's the 1 over u part, and then in the blue, that creates the du. That's just natural log absolute value of u plus c, which is natural log absolute value sine of 2x plus c. Not too bad, nothing new, right? Why don't you try to set up 3 on your own and pause the video, try it out, and then check your answer here in a second. How'd you do? Kind of trickiest part here, when we do this derivative, is I set u equal to the bottom, e to the 3x, its derivative is 3 e to the 3x, and then the plus x is plus 1. So in order to get this to match the top here, I just have to divide both of these by 3, so that's where that 1/3 comes from. For 4, this looks a little different. I just have a 1 on the top. I have x ln x on the bottom. I probably wouldn't want to make u the whole bottom, because then I've got product rule of x times natural log of x. But what if I just made natural log of x u? U equals natural log of x. That would give me the derivative, which is 1 over x. And another way to write this would be 1 over natural log of x times 1 over x dx. Hey, that's what I have here. So this is 1 over u du. 1 over natural log of x is the 1 over u. 1 over x dx is the du. So natural log absolute value of u, I can already kind of plug this in here, that's natural log of x, oh, weird, plus c. Natural log of the absolute value of natural log of x plus c. Now, another type of problem that we could see sometimes is using like a situation where instead of it being clear that the derivative of the bottom shows up on the top, they're balanced. It's like x squared on the top and bottom. And so what we can do is actually use long division to create a situation that's a little nicer. So you guys are very excited about this, I'm sure. So what we're looking for, like I said, is basically a rational function where the degrees are the same on the top and the bottom. So let's see what we remember about long division. X squared plus 1, we're going to divide that into x squared plus x plus 1. I only have to look at the x squared. It goes into x squared one time. Like x times 1 is x squared. So I got 1 plus. And then I'm going to take that 1, sorry, no plus, and multiply it here by the x squared plus 1. So I get x squared plus 1, and then I'm going to subtract that whole thing, bring down this x, because x squared minus x squared cancels out, x minus nothing is x, 1 minus 1 cancels out, so then I just get x here. That's my remainder, because x squared can't go into x. So now I have my remainder, and so this is the key. What we're really doing is we're rewriting this integral, or this rational function, as 1 plus remainder over x squared plus 1, what we divided by, dx. Cool. Because now, this part here is what we were doing above. Derivative of the bottom shows up on the top. So I can split this integral up. Integral of 1 dx plus integral of x over x squared plus 1 dx. This part is just x. Let's do the u substitution. U equals x squared plus 1. Du equals 2x dx. I just want x, so it's going to be 1/2 du equals x dx. So I'm going to do this off to the side here so I can go straight, keep my nice formal answer formal. So I've got x dx, the 1/2 will go in front, the x dx is the du, and I got 1 over u. So this is going to be 1/2 natural log absolute value of u plus c. So here I go plus 1/2 natural log absolute value of x squared plus 1 plus c. I don't need 2 plus c's, just 1 for the whole thing is fine. That'll work also if the equation is top-heavy. The rational function is top-heavy. The degree on the top is bigger. So let's finish up with this problem here. I've got integral of 2x squared plus x minus 2 over 2x plus 1. I'm going to get rid of that stuff so it's not in the way. Okay, so let's try some more line division. If you want, pause it and try it on your own. 2x plus 1 dividing into 2x squared plus x minus 2. 2x times what gives me 2x squared? I would need to multiply that by x. Then I distribute the x, 2x squared plus x, and I'm going to subtract that. So that gets me, those cancel out, just the minus 2. Then when I try to do 2x into negative 2, doesn't work. So now I'm at my remainder. So this is really x plus negative 2 over 2x plus 1. Integral of x plus negative 2 over 2x plus 1 dx. This will be x squared over 2 plus, and now I'm going to need the u substitution for this part here. U would equal 2x plus 1, du would equal 2 dx. I want it negative 2 dx, so negative du equals negative 2 dx. So I'm thinking that's going to be integral with a negative in front of 1 over u du. So this should be minus natural log absolute value of u plus c. So I'm going to have plus negative natural log absolute value of 2x plus 1 plus c. And there's my answer. Thanks for watching.